There we go. If I look at the graph of the exponential function, the domain is all real numbers. What's the range?
0 to infinity.
0 to infinity. We said that the exponential function has what we call a horizontal asymptote at y equals 0. So it has a floor at y equals 0. Now, what's that going to mean for us in terms of the logarithm? Okay. Now, I'm going to approach this a little differently. The domain, if I'm taking and going across, and the exponential function, it's what's taking me across, he has a domain of all real numbers. And he has a range of 0 to infinity. Now let's think about what happens. The logarithm brings it back. What's the only thing that's in his world? Numbers between 0 and infinity. So his domain's not all real numbers. His world contains only 0 to infinity. So when he looks there, he's got only numbers between 0 and infinity that he needs to bring back. Can't be. Well, why can't it be? Because does the exponential have negative infinity in his range? No. Negative infinity means what he's doing is he's going this direction. So if I'm thinking about how the y values go, it rides along, goes flat, and then reaches for the sky. So in the range, that's all that's there. So when logarithm comes back, he says, I only have numbers between 0 and infinity. You remember, this is the domain of log base b. Domain of log base b is 0 to infinity. So what's this going to mean to us? It means this. So that whenever you take the log of anything, it must be positive. Now, what you're taking the log of has a name, and it would be log base b of that thing. That thing we call the argument. Remember, rational functions have denominators, right? And radicals have radicands. Most functions really have arguments. And what this means to us is this. When I'm dealing with logarithm, the argument must be positive. The argument must be positive. So now we have three things going on. And I'm going to bring this over here to remind us. Domains of what we've been studying is all real numbers except. This should go on your note card for the final. 1, denominator can't be 0. 2, the radicand must be greater than or is equal to 0 for even index. And 3, the argument must be positive for log.
Is it greater or equal?
For the radicand, but not for the log. Why? Because remember this. I go back to the exponential function. The exponential function has a horizontal asymptote. It never reaches 0. So what's in the world of the logarithm are only numbers between 0 and infinity, not including 0.
Yep.
Because of that horizontal asymptote. So now we've got three things to remember. Sorry about that. And that's not on my notes online either, so.
Why is it called argument?
I don't know. They could have called it Fred.
Yeah.
You know, Fred must be positive. I don't, maybe, it's just something that once you get into, it's not unusual, especially if you're going to take college algebra, that you're going to talk about arguments of things, or in calculus we talk about arguments of things. And there are certain things that have special names, like the denominator, like the radicand, and when you get into calculus, you're going to have things called integrands, so that they have special names attached to them, but for the most part, and all functions have arguments. So if I take a look at even though we call it a radicand, it is the argument of the radical function. So it says like they ran out of names, You say, well, okay, now we've got special things. Now let's just call everybody, whatever else it is that's called arguments. It's like polynomials.
Yeah.
Monomials, binomial, trinomial, and they said, that's it, then everybody else, they're all polynomials from that point on. So here we go. Argument has to be positive. Now what's the argument? It doesn't matter what base the log is. That's what you're taking the log of. So that 3x minus 1 must be positive. 3x must be greater than 1, or x must be greater than 1/3. That's what's in his domain. The argument,
That's just this, just with x.
that's it.
1/3.
So this is the domain. So what I'm taking the logarithm of, which is 5x, must be positive, or x must be positive. In fact, the 5 is there, makes no difference. Again, what I'm taking the log of must be positive. What's the argument in this case?
2 minus x.
2 minus x must be positive. Minus x must be greater than minus 2. Or x is what?
Less than
Less than 2. Well, then what's the graph of the sucker look like? Well, remember you're reversing x and y.